All right, so we're going to go over some ways to use the Desmos graphing calculator that you have access to in your testing program. So there'll be a little icon at the top and the NC testing version will come up. You should have the graphing version. You may have the graphing and the scientific calculator. I would just stick with one. The graphing one will help us the most with our curriculum. If we look here on the screen, this little keypad will pop up, and this is what we're going to look at first. So we've done some things with putting in systems and things like that. We'll talk a little bit more about that. But this little toolbar, this little hidden keypad, gives you your variables, things to make something squared. So if I wanted to do like 4 and then squared, it automatically gives me the right answer. If I want to do some type of number, but I want it besides just a 2 exponent, maybe I wanted an 8 or something like 2 to the 8th power, then I'm going to use the one with the B. I like to use this one all the time. It's like the caret, being able to use any of them. Our absolute value sign is here. So remember, we can have multiple things going on. This is just like a calculator. It would be in your calculator. If you don't need it, you can close it out. Absolute value is here. So if I had, 7 minus 11, absolute value, it always comes out positive and you see your answer. If I put something in, like just a regular problem, like 2 divided by 8, okay, notice that it has in decimal form, and over to the side there's a button that you can hit, looks like a fraction, and it'll change it back to fraction form for you. Well, obviously 2/8 is a fraction already, but a simplified fraction. So if I want it as a fraction, I can click the little fraction button. If I want it as a decimal, I can click it as a decimal. Much easier than the little tool on our calculator. So you can do basic stuff, 6 plus 8. It automatically gives you can do multiple things, division, multiplication. You can use these tools or the ones on your keypad, on your MacBook. So if I was doing multiplying 2 times, that's with the shift and the 8, 4, it automatically does it, or I can use the times here. I have a decimal, I have pi. If I want to do a square root, I'll clear some of this for us to see. If I want to do a square root of something, say the square root of, say, 16, or 16, it'll automatically do it for me. If I want a square root in a problem and I want it to be like divided by something, notice that when I write it underneath, my cursor is still underneath the radical sign. I want it out, I will need to move my cursor over either with my little arrows on my keyboard or these arrows here. And maybe I want to divide that by 2. Then it will actually take the square root first and then divide by 2. If I don't do that and I don't move it out, it ends up being inside of the radical, which is a very different answer. So be careful of what you're actually wanting. So if you don't have the option, like on this one, if you don't have the option here to change it to a fraction, you know that it can't be, and this is irrational. This is an irrational number. So cube roots, which we talked about briefly earlier this year, cube roots are a little bit different. They're going to be in another place. There's a function here. The function, when you click it, you have some more menu options. The first ones here are trig options. That's more for math 2. We have some statistic options, which give us total, a mean, which we need to know how to use, median of something, a minimum. We also can, some of these other ones are more AP stats type situation, standard deviation, quartiles. The DIST are to be able to do a histogram or a box plot, distributions. We'll talk a little bit more about these. And then your miscellaneous is going to give you some more options. So you have the lowest common multiple, greatest common denominator. We'll use percent, and this here is our cube root. So it's got our radical sign with a little n. That n allows us to put anything. So we can put our cube, which would be a cube root, say maybe of 64, and then it'll give us our answer. So that's in the function button. We also see that there's a fraction type look, a logarithm, which is also math 2 and math 3, so you won't need those. And so a couple of these other ones you won't use, but kind of know where they are. All right, so we're going to talk about finding the lowest common multiple. So if I'm trying to find the lowest common multiple to either factor or find something out, and let's say I have the numbers, I don't know, just 3 numbers. I can go into this function that where I'm at, and I can go over to this miscellaneous, and when I look and see what I'm looking for in lowest common multiple is here. It's going to bring up a parentheses, and maybe I put, I don't know, 4, 12, and 42. I want to know what my lowest common multiple is. It automatically tells me. So I just had to put a comma in between. If I want to find my greatest common denominator, again, I go into the functions, greatest common denominator, what can go into all. So if I'm clearing fractions, this is helpful. So maybe I'm doing 36, 84, and I don't know, 120. It will tell me immediately what is a number that all of them are divisible by, greatest common denominator. So that's a very helpful feature as well. If we want to find the total of something, let's say we're doing some data and we want to find the total, we can go into our function again. Notice that would be something with like statistics. And so we want a total of something. Maybe I want to add up a bunch of numbers. So maybe 3, 5, 8, 11, oh, I didn't mean to put dots there, commas, 5, 8, 11, 31. And it automatically adds them up for me. That's the total amount there. So it does a total for me. So let's say I want to find the mean of something, which we know is the average. Again, into our functions, our stat is where all those number calculations come from. So let's say I want the mean of something. So maybe I was finding the average of some scores on a basketball game or something like that. So maybe I had 52, 60, 24, 52, I don't know, 61. So it's going to find the average for me, okay, the mean. I can also do the same thing for the median if I want to find the middle value in a set of data. The same thing will work for percentages. So if you're wanting to find a percent of a number, let's say I wanted to know what 8% of something was. So I can put in 8, I want 8, and I want the percentage. Again, I can use my little functions, my miscellaneous, I have a little percent. So I want 8% of, maybe I want it of 298. It immediately tells me what 8% of that is. So this helps us not to have to remember all the pieces and parts. We can also do multiple things like a percentage of something times something else. So maybe percent of 298 times 53. It immediately does that for us as well. Using parentheses is helpful, but it's not always required in Desmos. Again, we have this fraction. We can click it and see what that is in fraction form. It always gives it to us in the simplified version. Now, to find these in with systems we've done, with systems of inequalities, you're going to get into this week, and I don't know that you'll see much on your check-in, but if you have an inequality problem with a system or just an inequality problem in general, so let's say I have 3x plus 7, and I have my greater, less than, greater than or less than or equal to little symbols here, and maybe it was greater than 5. It will automatically graph for me, and all the area that's shaded would be where the solutions would be. Because it's a dotted line, those are not included in our options there. So this is x. If we look at here, x is going to be greater than 0.667. So it's anything greater than that, not including that. So you can put them in as well. If you have an inequality system, let's say you have, this is one of them, and you have, I don't know, 2x minus 8 here and here. A system is where they overlap. Those will be your solution sets. So that can kind of help you see that a little bit. The same thing with absolute value inequalities as well. You'll be able to see if you put an absolute value inequality in. So let's put one in. We'll say the absolute value of x minus 8 equals, well, not equals, we'll say greater than 4. So notice it automatically graphs for us. The little home button gets us back to like kind of the norm. If you want to check, always make sure on inequalities that you check, because we've got lots of different options there, because remember we can have a negative and a positive number because it comes out positive. All right, to be able to write equations, or to put things in and then write equations, that's where we get into a little bit more different things we have to do. So let's say we have a problem where it's just a basic equation and we want to know the solution to it. So let's say we have 3x plus 4 equals 5x minus 2. If I put it in just like this, it gives me an arrow. So what I have to do is put one side of it in, and on another line put the other side in. And I use x and y's regardless of what it says in the problem. Now notice it's still, because I have an equal sign here, it's saying what's an equal. I always just set it equal to y, set both of them equal to y. This will still work. This is just it looks like a system now, but we started this as an equation. So I just put one side in one line, one side in the other, and where they intercept is the solution. And I'm just looking for the x. So my solution to that original problem would be 3. So, and then you can double check and make sure it actually works. 3 times 3 would be 9. 9 plus 4 is 13. Same thing over here. 3 times that's 15 minus 2 would be 13. So 13 does equal 13. All right, so when we get into equations and tables, there's a couple different things we can do. If we're given some points, let's say we're given just 2 points and we want to make an equation, for example. Well, I'm going to give you 2 points. I'm going to add a table, that's by the little plus, add a table. And notice it says x1, y1. So I'm going to go ahead and put in some points, say 3, 5, and 2, 8. Now, it will plot them for me. I don't show as a line. If I hold this down and turn the little line value on, it will connect them. Now, that's not going to help me make an equation yet, so I have to do something else. So on the next line, after I've put in my table, I'm going to type in this formula. We know that if we're writing it into a standard linear equation, y equals mx plus b. Desmos doesn't understand y equals mx plus b by itself. If I do this, it will just ask me to add sliders. I don't want to do that. I want to use the values that are up here in my table, this x1 and y1. So I've got to tell that equation that. So I do y1 and then mx1. And now what it does, it's going to use those values in the table. However, you see that all of a sudden I've got some things going on. So we can't say equals because it doesn't actually understand that it equals. It's estimating it based on what we put in the table. So we're going to take the equals out. We're actually going to use what's called like an abrev. It looks like a little squiggly line. It is found in your functions, and if you go to your, actually it's not in your functions, I'm sorry. If you go to your ABC, where you can get to the rest of your things, it is literally right under the Z. It looks like a little abrev there. That goes in between. So now what happens, it does give you some residuals, which is something you'll learn later this year, but your parameters is what you're looking at. So this equation is actually y equals negative 3x plus 14. So we can put that now in as y equals negative 3x plus 14, and notice it's exactly the same line. So that is the equation from those points. So again, we put the points in, we put in this formula, y1, whatever's up here, the little abrev, approximately, or is mx to the 1 plus b, and it takes these points and puts them in there for us. If we have this already in and we have something else that we need to do, we take these out, and this is kind of just like a placeholder we can then use. Notice that it's now just having a little sign that tells us, uh-oh, something's wrong. When we put more points in there, let's say 4, 5, 11, negative 2, it's now going to give us again the slope and the y-intercept. So that helps us as well. All right, so let's say we go to something with an exponent of something squared. So if we have, let's say, a function, it gives you something like an f of x, and it tells you that it is 2 to the 4th raised to the x power. That's exponential. It's our unit we're going to be getting into next. And we want to know something about that. If we ever want to take this value, this equation, and turn it into a table, once we have it in there, we can click the little gear, and these buttons will come up, and we convert this to a table. It always gives us those standard ones. So let's say this was telling us how much bacteria increased each day. Maybe we want to know how much bacteria was in after 10 days. So we could put in 10 for the x, and it would tell us how much is in there, which is a huge amount. It's a scientific number. Maybe if we want to just know 3 days, we have 128 bacteria. So this will help us solve and answer some things exponentially. Let's say we have a function that is squared. That makes a parabola. That's a quadratic. And we wanted to know some values. Automatically, it's got our table fixed for us already. It matches with this. So maybe we want to know what the value of y is if I put in 8 for x, and it tells me immediately. Now, it doesn't tell you as easily going back the other direction always. If you put in something for y, it won't tell you what the x is. That's where you have to do some calculations. But this is helpful. When you get into something where you want to know a possible answer to quadratics, a lot of times it will give you a root. And so let's say we have 5x minus 11. Oops, sorry. Minus 11. So notice here what shows up is our roots, and if we're trying to find out what possible answers they could be on our x-axis, what our x values are our roots. So this is by no means a detailed explanation of how to use every function, but the activity that you're going to do today is going to do a lot of these, and you have a key that you can look at, the kind of the process of how to do certain things to help you find those answers. So this is about using this so that when you have your test, you can use it in the check-in process and in your EOC, so you can use it very well. It's much easier than our calculators.